Today we're looking at 8.2 using Pascal's triangle. In my last video we talked about problems 1 through 3, which is using Pascal's triangle to expand a binomial. Now we're going to use Pascal's triangle to evaluate each expression. So this first problem, number 4, has the parentheses with the 6 and the 2. The way we would read this is 6, choose 2. And what it's actually asking is, if you have 6 different items and you want to choose 2 of them, how many different combinations of 2 items could you choose? And we can figure this out using Pascal's triangle. So 6 choose 2 means that I want to look at row 6, term 2. So I'm going to pull up my Pascal's triangle, and I want row 6, term 2. So here's row 6 right here. And remember, the first term is actually term 0. And then we have term 1, and term 2 is a 15. So I know that this answer is going to be 15, meaning that if I had 6 items and I wanted to choose out 2 of them, there are 15 different combinations of 2 items that I could choose. If you look at problem 8, which says 7C3, well, that actually means the same thing. This means 7, choose 3. It's just simply a different way of writing 7, choose 3 that we did a moment ago. So the process will be exactly the same. We're going to look at Pascal's triangle and find row 7, term 3. So I go to my Pascal's triangle and I look at row 7, which is right here, and I want term 3. So here's term 0, term 1, term 2, and term 3 I see is 35, which means that my answer here will be 35. In other words, if I have 7 items and I want to select 3 of them, there are 35 different combinations of 3 things that I could choose. Now in this next section, we're working with these exclamation points. Now the first thing you need to know about it is that this exclamation point is called a factorial. And what it means here on problem 10, for example, where we have 4 factorial, that means that we want to multiply 4 times 3 times 2 times 1. So I'm just going to get out my calculator and type in 4 times 3 times 2 times 1. And my calculator says that that equals 24. So I know that my answer here is 24. All right, well, if you look at problem 12, we have 12 factorial divided by 9 factorial. Well, I know that 12 factorial is 12 times 11 times 10 times 9 times 8 times 7, and so on. But instead of writing all of those terms out, I'm going to write it as 12 times 11 times 10 times 9 factorial. And the reason I did that is because I see that it's being divided by 9 factorial. Now, I don't know what 9 factorial is, but I know that if I have a 9 factorial on top of the fraction and a 9 factorial on the bottom, they'll cancel each other out. And this problem becomes 12 times 11 times 10, which, if I type that into my calculator, 12 times 11 times 10, it equals 1,320. So I know the answer is 1,320. Last but not least, we have these 3 story problems. So number 16, 7 students are hoping to be on the prom committee. If there are only 4 positions available, how many different committees can be formed? Well, notice we have 7 students and we are choosing 4 of them. So we can write this either as 7 choose 4, or we could also write it as 7 choose 4, because remember, these two notations mean the same thing. Now, to figure out how many different prom committees we can create, we're going to look at Pascal's triangle. Row 7, term 4. So I pull up my Pascal's triangle. Here's my row 7. And for my 4th term, we'll remember we had term 0, term 1, term 2, term 3. And here's term 4, which I see is 35. So back on my problem, that means that there are 35 possible committees that could be formed out of these 7 students. Now that you've seen this video, go ahead and try to finish out this assignment.